Hello everyone, welcome to next round coding. Today going to solve Leetcode 3947, maximum number of items from cell 2. Basically the problem asks that we are given an array of items and the items have two components, one is factor and price, and we also given an integer budget, and there are unlimited copies of each item available for purchase. You may buy any number of copies of any item such that the total cost of purchased copies is at most our budget. Now, for buying items, we may receive free copies according to the following rules. If we purchase copy I, means the copy of ith item, we can get at most one free copy of another item j. Now, what are the conditions? I should not be equal to j, and factor I divides factor j. And for each ordered pair ij, you can receive a free copy of j from the purchase of item I at most once. Means we can get the free copy of buying the item I, getting the item j as a free for only at most once, right? Regardless how many copies of item I you buy. Now the same item j can be received multiple times for free if it is received from purchase of different item types. Yeah, so same item j can be received as a free copy if any other I validates these conditions. Okay, and we need to return the maximum total number of item copies we can obtain, including the purchased copies and the free copies, while spending our budget on the purchased item. So if you're not able to get this problem yet, let's understand it properly. So the problem states that we have a 2D array of items, and items have two things. One is factor and one is price, and we have an integer budget. Now we can buy as many items I as we want because there is unlimited supply of any item. Now if we buy ith item, we can get a free jth item. How? The condition will be that I should not be equal to j, and our factor of j should be divisible of factor of I, right? And for each ordered pair of I comma j, we can get the jth copy as a free only at most once, right? For this case, suppose we buy this item, the zeroth item, and the factor here is 1 and the price here is 6. And if you see this item, the factor is 2. So 2 is divisible by 1, right? So if we buy this one, we can get this as a free, right? Now again, if we buy this one, we can't get this as a free because we can get it at most once, right? So suppose we buy this the zeroth one, we get this one is the first index one as a free. Okay. Now again, if we buy the zeroth item, if you see the factor here is 3, 3 is also divisible by 1. So we can again get our second index one as a free. So if we buy again this one, we can get second index one as a free, right? So if we buy 0th one, we can get the first one as a free. If we again buy the 0th one, we can get a second one as a free, right? Now, for this case, we have spent 6 here because we the price here is 6 and we get this as a free, so only 6 cost will be there, and for this case it again 6 cost will be, and we have spent 12 here and budget is here 90. So we have spent 12 over here and we have 19, so we have 7 left over here, right? So we can buy any one. We can buy, just suppose we buy the second one. Okay, we buy the second one, then our remaining budget will be 7 minus 5, which will be 2, right? And once it is 2, we can't buy anyone because all the price over here is greater than 2. So how many we are able to buy here? And we got free as well. So we have buy the 0th one first and the first one as a free. So 1, 2, here is the 3 and 4, here is the 5. So total we get 5 items and we need to maximize it, right? And for this case, the 5 will be our answer. There is no other ways to get it more than 5. So that's why 5 will be our answer. Okay. Now let's see the approach over here. Now suppose somehow we got a 2D array which tells us if we spend this price, we can get this number of free items. Suppose this somehow we have generated this array. Okay, so there will be some p1 comma n1. If we spend this p1 price, we can get n1 free items. There will be some p2 n2. There will be some p3 n3. Now how we came up to this will come up later. Okay, now just understand we have come up with an array which have two components. One is price, one is number of free item. So if we spend this price, we can get this number of free items. Now, as you know, we need to minimize the spending of money, right? And we need to increase the number of item we get, right? Either it purchased or it is free. So if we have this array, if we want to minimize our spending, so we'll just sort it. So suppose we sort it, and after sorting, it is come to this p1 n1, p2 n2, and p3 n3. So after sorting, it come up to this, and we have sorted according to our price. Okay. Now suppose we have get all free items. Okay. We have get all free items. Now if we want to buy a new item, we will get only one item. Okay, we can't get any free item because we have already get all free items. There are no other pair of I and J which support us to get a free item. Now at that point, should I spend our money on an item which have a price more than our cheapest price item, Should I spend our money on a items which have more price than our cheapest price? No, right? Because if we spend our money in a expensive item, it will get it will give me only one item, right? If we buy our cheapest price item, there we also get our one item. So as you know, we need to spend less money and need to get high number of items. So it is always preferred that we will spend the cheapest price always if we already getting one item only, right? So now suppose we have an answer here and we are only buying the cheapest price item. Okay, so we have a budget over here. So current budget will be our budget, and if we just buying the cheapest price item here, so how many we can buy here? So current budget divided by cheapest price item, right? Now let's take a variable buy one get one. Okay, initialize with 0. Now let's iterate over this array. Okay, so how much we can buy? So our can buy will be, we have a current budget of this, and we can spend P1 over here, so we can get this number of times, right? And we have a limit over here is N1. So minimum among this we can buy, right? Whatever the minimum among this or current budget divided by P1, because this number of times we can get it, and we have a limit over N1, so we can buy minimum of this, right? Now if we able to take this, suppose I am naming it as a take. Now if we taking this, our buy one get one will be updated with our take, and our current budget will be updated by this P1 into our take, because this price we are spending. Now total how many items we are getting there? So there will be some buy one get one, and buy one get one gives us two items, so it will be into 2, right? And as I told you, our remaining budget means our current budget will be spended by the cheapest price item, right? So it will be by cheapest price. So total this we can get from here, and we just need to maximize it. So our answer will be max of answer comma total, right? Now for again in the next iteration we'll consider P2 and 2 here. Again check how much we can buy here. It will be again minimum of current budget divided by P2 comma N1. And if you are taking it, so our buy one get one will be updated by the take, and our current budget would be reduced by 2 into take again our total number of items we are getting after taking P1 and P2 will be buy one get one into 2 plus whatever the current budget will be at that time divided by our cheapest price item. Again, we will maximize our answer. This way, at the end, we can return our answer. Right. Now, come to this. How we come up to this array. Right. We need to know about it. Now, as you know, the items have one factor and one price, right? And we need to find out the number of free items we can get if we spend some price P1, right? So let's count the frequency of the factor. So let's count the frequency of the factor in the items. So let's take a vector or a map, whatever. So I'm taking here a vector of int frequency of size n plus 1 because factor can be at max n and initialize with 0. Okay. Now just calculate the frequency of the factors. So auto it items, just do frequency of it of 0 plus plus. Right. Now I get to know how many 1 will are there, how many 2s are there as a factor, right? Now suppose you have factor x, okay, and we need to know now how many items have factor divisible by x. So for this case I am creating a divisible array, okay, divisible array of x which is defined how many items have factor divisible by x, right? So let's create a divisible array. So vector of int divisible, it is again n plus 1 0. Now let's iterate for all of them. So for int x equal to 1, x lesser than equal to n, x plus plus. Now we need to find the multiple, right? So if you know sieve, then you can do it easily. For int multiple starting with x or multiple lesser than equal to n, we will just do multiple plus equal to x, because if we do plus x plus x plus x, this will be our multiple of our x, right? So divisible of x will be plus equal to our frequency of multiples, right? Because we have already calculated the frequency of the factors. So for x, we have calculated the how many items are there which a factor is divisible by X, right? Okay, great. Now, as I told you, we need to create a array where we have a price P1 and number of free items N1, right? So now let's create a vector of int name as a ARR, which will store the price and number of free item we can get if we spend this price, right? This will store arrays for storing this, right? Now we iterate over the items. So let's iterate over the items. Now let's check the factor over here. It will be item of 0, right? And the price over here it of 1, right? So now how many free copies we can get? So I am naming as a n1 as a divisible of factor. This much we can get -1, because if we buying this item, we can't get this item as factor because I not equal to 2, right? That's why -1, and we can then just push it into the vector. So if our n1 is greater than 0 only, then we will push it here, the push back as a pair of our price and n1, right? And that is all. After this, we'll get this array, and if we able to get this array, then we can easily do these steps and we will get our answer at the end. So I hope you have get the approach over here. Now let's see the code. We will get it better. Okay, now let's see the code over here. So we have a n, which is items.size, and as I told you, we need a vector to store the frequency. So frequency of n plus 1 comma 0, and let's iterate over the items. And do frequency of it of 0 plus plus. Now we need again a vector of divisible, right? Again of n plus 1 size. And says it's 0. Now let's run a loop. Let's take it as a x equal to 1, x lesser than equal to n, x plus plus. Now again a for loop, int multiples as x and x lesser than equal to, sorry, it is multiple lesser than equal to over n, and multiple plus plus, not again plus plus, it will plus equal to x, right? So our divisible of x plus equal to frequency of multiple, right? This is done. Now, as I told you, we need a array to store the price and number of free items you can get. So let's take a 2D vector. Here, right? Now let's iterate for items, and let's do here a check what is the factor over here. It of 0 and the price it of 1. And as you know, we need to find the cheapest price, right? So let's create int cheapest price as suppose 1 is 29, 2 is 9. Okay, and just do that cheapest price equal to minimum of cheapest comma price. Now, as I told you, we need to find the count. So just name it n1, and as I told you, to be divisible of factor -1, as we can't get a ith item as if we buy ith item. So that's why -1. Now, as I told you, if it n1 is greater than 0, then we only push arr dot push back our price and n1 done, and at the end we will sort it. Done. Now let's create some variable and our budget, which is our budget, and int buy one get one as 0. Right. Now let's iterate over the array. Error. Now there will be a price which will be it of 0, and there will be a limit which will be it of 1. Now we can take what take will be minimum of our current budget divided by our price from a limit, right? And we will update our buy one get one plus equal to take, and we update our current budget minus equal to take into our price, right? And our total will be buy one get one, buy one get one into 2 plus our current budget divided by the cheapest. It would be cheapest price. So cheapest price, right? And that's all. Just update our answer as a max of answer from our total, and at the end just return our answer. That is it. So let's run it up. So it will be mini, not it will be mean, and run it. We have not declared our answer. Sorry. So we need to declare our answer again. Answer will be whatever we have budget over here divided our cheapest price, right? And that's all. Now let's run it. Yeah, it is running fine. Try to submit it. Yeah, it is accepted. Now let's analyze the time complexity over here. So we are running a loop over here, which is big of n. Now in this case, it might seem that it is big of n square, but no, it will be big of n log n, because it is going something like this: n by 1 plus n by 2 plus n by 3. This way it is going, which would be nothing but n log n. Okay, so this is n log n, and it is again big of n. Sorting takes n log n, and again it is big of n. So the time complexity here is big of n log n, and the space complexity is big of, check it out, we are using a n size array over here, again n size array, and here is 2 n size array and nothing else, so it will be big of n. So that is it. Thank you.